Welcome to Operations Research Sensitivity Analysis Lecture Series by Professor Joyjeet Ghosh. This is the fourth lecture of a 4-series lectures. This lecture will be on Introduction to Sensitivity Analysis, Need of Sensitivity Analysis. He will also be discussing the sensitivity analysis of change in the objective coefficient of a basic variable by revised simplex method. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hi friends, welcome to this fourth lecture of a 4-lecture series. In this lecture, we'll be discussing the sensitivity analysis of a change in the objective coefficient of a basic variables, and this we'll be doing by revised simplex method. So if you are conversant with the revised simplex method, then only proceed watching this video, or you may omit this video. So it is expected that you are conversant with the revised simplex method, and it is expected that you should be solving this problem by the revised simplex method, which we have already discussed in the first 3 lectures. This is the problem that we will be solving, and for this problem we will do the sensitivity analysis for change in the objective coefficient of a non-basic variables. So first we will solve it by revised simplex method. So at this point, if a solution is not in front of you, I would advise you to stop this video or pause this video at this point and then solve that by revised simplex method, and then follow the lecture. That will be better for you. So in this solution, if it is this is the third iteration, so this is the final solution here. You can see the third iteration start with x3 is equal to this, and x1 is equal to this, and this is the solution. So what is expected in this problem? So in this problem, the basic variables are x3 and x4. We'll check the coefficient of the basic variables. The coefficient of basic variables in the objective functions are 4 and 5. This is the basic variable, and this is the basic variable. If either of these changes, then how does it affect my optimality of the solution? How does it affect the optimality? Let us take it for example. Let's say 4 is changed to C1. If 4 is changed to C1, what is the range of C1 for which it will still remain optimal? And then if we'll take a value of C1 outside the range, and we'll find out the optimal solution. So this is what we are planning in this lecture. So this is my solution here. Now what is affected? Let's see. In this iteration, when this is changed to C1, so this is affected, y is affected. When y is affected, all these values will be affected, because all these are dependent on the values of y. So let us carry out this step again. So y we have found out 5c1 into b inverse. So this comes out to be this row matrix of this, and then we'll find out c2z2 and c4z4 and c5z5. So it comes out to be this, and this. So all this has to be less than equal to 0, less than equal to 0. So for this to be less than equal to 0, we get c1 greater than equal to 10 by 7, c1 less than equal to 10, and c1 5 by 3. So for all these values, we can decide the range 5 by 3 less than c1 equal to c1, and c1 less than equal to 10. So within this range, all values of c1 within this range, the solution will be optimal. Once the value is outside this range, then the solution will not be optimum. For example, if c1 is equal to 9, then the solution will remain optimum. If c1 is equal to 12, then solution will not be optimum, and we have to find out the optimal solution. So let us find out the optimal solution for c1 equal to 12. So we'll replace this by 12, and we'll find out the value of y. Once you find out the value of y, then we'll find out c2, c4, c5 and check whether they are optimal or not. If they are not optimal, then we'll again carry out the iteration by simplex method, and then we'll solve it. So this is how we'll be solving this. So thank you for watching. If you have any doubts, please contact me. Thank you.